Actually, I'm not even going to draw that. There we have it. Thing 1, thing 2, balloon in the middle, floating in the air. Angle of elevation from one side is 40. And angle of elevation from the other side is 50. The distance between the two is 100 meters.
Wait.
Okay, so this is a challenge question. Yep. We are looking for this height. Thoughts? Yeah?
Wait, what are you looking for? Sorry.
The height of that balloon.
You know the other angles at the top because.
Hold on. Okay, here's why it's such a big problem. Even if I were to divide this triangle in half, do I have two pieces of information for the left triangle?
Yes. Don't you?
No.
Because don't you?
You have that middle angle.
Wouldn't it be that it's 50 meters? Because if it were,
It's not half.
It's not a half.
You can't say it's, if it was perfectly half, wouldn't these two angles be
The same.
the same, right? So we can't argue that. So we don't have full information on the left side. You don't have full information on the right side. We're stuck. Coincidentally, I gave you 40 and 50 for a reason. However, I want to show you a second way to do a solution where even if I don't have the right angles, the proper angles, then we can't do it. So John mentioned before, or an earlier day when he was trying it, that 40 and 50 add up to 90. And the three sides of the three angles of a triangle must add to 180. Therefore, by default, this one has to be 180 minus the 40 minus the 50, which is the same as minus 90. So you have 90 degrees. All of a sudden, I have a 90-degree triangle, where this is the hypotenuse.
Hold on.
Yeah.
So if I have this hypotenuse,
You have one.
using SOHCAHTOA, can you find other pieces of
Yeah.
information?
Yeah.
There you go. So let's piece it together. Go ahead.
Oh, so
I guess it would be 50, so you have the hypotenuse and then
Which angle do you want to work with?
50.
Sure. If this is 50, that's the hypotenuse. This side would be opposite,
That would be 50.
and this side would be adjacent. At which point you can choose. You can choose which side do you want to calculate to help you find that height. Sure. So if we have opposite and hypotenuse, we have sine of 50 degrees is equal to the opposite side, which I do not know, divided by hypotenuse. And so how long is that opposite side?
76.6.
Someone's going to have to do that on the calculator.
76.6.
76.6 meters is my opposite. Great.
Wait. I get it.
Okay, excellent. Here's the next step. I'm not done. The question asks for the height, but let me update my picture. Can you find that?
Yeah.
How?
Oh, you can do something with 40 and 70.
Right, because it's another smaller triangle, but the SOHCAHTOA relationships don't change just because we have a different triangle. Now we have, let's break that down. We have, no. Opposite, again, of hypotenuse. So we have sine of 40 degrees is the opposite side, which is height, divided by hypotenuse, which is 76.6. So my height is going to be 76.6 multiplied with sine 40. So
49.18.
39.
49.
49.12.
Well, because when you round one.
Right. 3, I guess 1 significantly, 2, 49 point, sure. Sure. Okay, the height is 49.2 meters. Great. Questions so far? Yes.
Why did you do the 76.6? Oh, wait. Like, why'd you for sine 40? Like, height over.
Here, after we calculated 76.6, we're looking at that now. So 40 degrees opposite over.
Oh, okay,
So
okay.
you just gotta figure out what triangle you want to work with, and the rest of the math is still always the same. Here's my challenge to you. I'm gonna change this up. This is 50. What if this was like 31? Can I say this is 90 degrees?
No.
No. We're stuck. But we're not. So I'm gonna do this on a second example, okay? And this one is gonna really stretch your brain. Why? It involves, well, non-right angle triangles, okay? It will involve your SOHCAHTOA trigonometry. It will also involve substitution
Substitution.
with two variables.
Like from like 4 units ago, substitution.
Substitution is not something that's contained by a chapter. Substitution is a technique that you can use even when you're like 30 years old. It doesn't disappear on you. Okay? Alright, here we go. So, assuming, let's pretend we don't have a 90 degree. So I'm going to block off this method. Alright? This is method 2. And so, by condition, this is only possible because we know that's a 90 degree triangle. If we don't know it's a 90 degree triangle, you ready? I'd like to challenge you to think about it like this. If this is 100, right? I'm going to still force myself to break this apart into 2 pieces. If you remember an example that I gave as a warm-up, if this distance was called x, by default, what is the expression that we can use for that portion?
Y.
Yes, that's a logical letter.
100 minus x.
100 minus. I don't want to introduce another variable if I can help it. This is 40, and this is 50. Are you ready? Let's pretend we can't use that. That's the whole purpose of this. Okay? So I'm going to still use these same numbers so that I can get the same number here, the same answer. But I want to try doing it a different way. Do you remember, or do you notice that this height is common between both triangles?
Yes.
So if I could find an expression for this side, and I could find the expression from this side, the left side and the right side should be
The same.
the same, and that's the key. I'm making a comparison, just like everything else in math. I'm making a comparison, I make a relationship. Yes?
On the test, if you give us an equation like this, or a question like this, will you ask us to do both methods or just choose one?
You can choose one. However, the reason I'm giving you this is if I give you these numbers and they don't happen to add to 90, what are you going to do? You're stuck. You can't do this. So consider this idea.
Would you give us those
Opposite
numbers that don't have to
over
happen?
adjacent. Tangent of 40 is the height divided by x. Would you agree?
Yeah.
Okay, let's go on this side. Tangent of 50 is equal to height over?
100 minus x.
Oh.
Yeah, really nasty. But do you see a somewhat of a similarity between the next number? Okay, so I am trying to compare height. I'm going to get height all alone. How do I get rid of divided by x? Multiply both sides by x. So this becomes x times tan 40 equals height. And for this one, don't be afraid, it's still a number. 100 minus x times tan 50 equals height. this height is the same as that height. I'm gonna put it together. Can someone do tan 40 for me? That's not, you leave it here. I'm just gonna calculate it as a decimal and then I'm gonna start putting stuff together.
0.76.
0.84.
0.84. So 0.84x is equal to, what's that?
1.19.
Yeah.
Okay. Do you see what I did? No.
Wait,
So this is height, and that is height. So this and that are the same.
Oh, what?
Oh.
I don't get it still.
If both sides of them equal.
Keep considering it. Consider this picture,
Both equal height and they
right? So I could use this equation to describe the height. I could use that equation to describe the height because they're one and the same heights.
Okay.
But this is obviously a different equation, and that obviously gives me a different equation because they're different triangles. But at the end of the day, we're still talking about the same height, so I'm going to make those two equations
So they
equal to each other. And so let's continue. I have this, and ooh, I don't like that. Can we simplify it by expanding?
Yes.
Someone's going to have to do 100 times this for me, and then negative x times that I can do in my head. So
119.2.
So 119 minus,
Point 2.
oh,
0.2.
Yeah.
yeah, so 192 is what she was saying. So 119.2, sure, minus 1.192x. Okay, not just a regular algebraic expression. Can we get x together, group-like
Yes.
terms?
Yeah.
Someone's gonna do that for me.
0.84
So 0.84x
plus.
plus 1.192x equals 119.2. And then someone's gonna have to do this. Let's bring it over to this side. So it becomes, ooh,
It becomes 2.032.
2.032x equals 119.2. So x is going to be 119.2 divided by 2.032.
That is equal to 58.66.
Update that picture. This side is 58.66.
Which means the other side
Is 40 or 30 something. So it looks like it was impossible, but by making a comparison, as always, you're able to do things that you normally might have been stuck with. So let's take a look. If this, let's update that picture, okay? Just like before. I'm gonna erase that. If this is 58.66 and I'm looking for the opposite, this is tangent. Tangent of 40 degrees is equal to the opposite side over this.
Wait, why did you do tan of 40 and then one?
I could do 50 if you want.
Oh, you can do either.
Yeah, of course. I just, before I erased that right side, I just thought I'd make a parallel.
Okay.
So height is 58.66 multiplied by tan 40. Someone's going to have to do that, or maybe you don't have to. What do you think it's going to be? It should be. Someone want to test that just to make sure? It should equal about 49.2.
which is 49.221.
Wait,
All based off of
but
comparison.
how is only the entire thing so I can't remember. Never mind. I get it.
Okay?
Yeah.
It's not necessarily intuitive, but it still builds off of playing with numbers, introducing a variable that you may not have imagined at the beginning, and then putting them together. Just like before, two triangles, we're simply trying to travel between one and another. There's my challenge question to you.